All right, greetings, geometry students. I appreciate you finding time to tune in and take care of your notes. I'm going to go through today's notes in a little bit greater detail, especially the Cornell formatting, just in case we have some new students that have checked into the class at the beginning of the semester. And let's face it, some of you guys that have been around for the last semester need a little refresher on how you're supposed to be taking your notes anyway. Okay, so we're going to give you a few extra instructions as we go through the notes. Let's get started. Today's title is Quadrilaterals. You need to write that down on your notes. Okay, this will be over on the left-hand side. Where you start your new notes. Write the word quadrilaterals. Some of you have been skipping the title, and that's causing you to not even know what you're looking for when you're flipping back through your notes, trying to figure out what's what. The next thing you're going to write down is your objective. Okay, so also drop down, skip a line on the left, and write the word objective. And then in the center and right part of your paper, write your objective. And your objective for this day will be the student will learn the various names, categories, and properties of the quadrilaterals. Now, in order to kind of keep the notes moving along as quickly as possible, I try not to leave any dead air where I'm not really saying anything. So if you find yourself in need of more time to copy something down, you need to either hit pause and then hit play when you're ready to move on again. Or if you miss something, you can always rewind in your viewer and hear it again. But there's your objective. Hit pause if you need more time. If not, here we go. Okay, now you have the term quadrilateral. This is something that we talked about as we were doing the basics of polygons. But this entire unit is going to be getting into quadrilaterals, so we probably need to go ahead and write this definition down again. We are basically finished with our three-sided polygons. Now we're moving on into the four-sided polygons. And of course, the definition we had from once upon a time for a quadrilateral was any four-sided polygon. So the word quadrilateral ought to be in the left-hand column of your Cornell note format, and then in the center and right part where you write all your detail information, you've got your definition here, a four-sided polygon. Okay. Now, the term parallelogram is not a term that should be new to you, something you should have heard in the past, and you probably even have a fair idea of what it is. Now we're going to be looking a lot deeper into the parallelograms, but the basics is a parallelogram. There's a new definition, new term for us, so on the left-hand side, and our definition is a quadrilateral that has a special property. And hopefully you can remember what that special property is, and it is, generally speaking, is that it has both sets of opposite sides parallel. Okay, so to put that in a pictorial form, this is what, generally speaking, a parallelogram looks like. Okay, and I use the term looks like very loosely because we all know by now it is very dangerous in geometry to go by the way a shape looks. We're always looking for the properties. We're looking for the math that actually makes a shape the shape that it is. Okay, so here we have both sets of opposite sides being marked as being parallel. That is a telltale indicator of a parallelogram. Now on this diagram in your notes, if you will draw it fairly largely, then you can actually put some of the upcoming properties in this same diagram as well. So if you will draw this parallelogram, maybe so that it takes up, 4 or 5 lines in your notebook paper, you can probably save yourself a lot of space here in just a moment. Okay, now I'd mentioned earlier that there are other properties that go along with being a parallelogram, so here they come. Okay, other properties in a parallelogram that arise because those opposite sides are parallel. Now when you take a quadrilateral and you force its opposite sides to be parallel, here's some other stuff that happens. It also forces the opposite sets of sides to not just be parallel, but to also be congruent. Okay, so write that down, and this is in the center and right part of your paper. This is a supporting point. The opposite sides are congruent. And if you want to, maybe even with some separate colors, go back to your original parallelogram that you drew and add in the appropriate tick marks. Now, if you drew your picture too small and you don't have space to do that in your original parallelogram, that's fine. Just draw you a new parallelogram. Mark the opposite sides parallel, and also mark the opposite sets of sides congruent. Now you'll notice that on the tick marks we have two different styles of tick marks in there because it is the opposite sets of sides that are congruent, but we do not know that all four sides are congruent, just the opposite sets. Another property that happens when your quadrilateral has both sets of opposite sides parallel is that that will force the opposite sets of angles to be congruent. Okay. So add that in to your picture or draw yourself a new picture if you didn't leave enough space. Our opposite angles are congruent as well. And once again, please notice the different styles of angle congruency marks. They don't all have just one mark or just all have just two marks because it's just the opposite sets that are congruent. We do not know if all four of those angles are congruent or not, just the opposite sets of angles. All right, another thing that happens when your quadrilateral has both sets of opposite sides parallel is your diagonals will bisect each other. Now, we caught a definition for diagonals a while back. We haven't talked much about them, okay, but we're going to start to see them appearing in our shapes more and more often. Okay, so the diagonals, which connect the vertices that are not consecutive, okay, like those green guys in your picture there, they will bisect each other. Okay, so whatever those lengths are of those green diagonals in the picture, they are chopped in half by each other. Once again, please notice the different styles of tick marks. Okay, so if you are adding this all into one diagram from the beginning, then you might want to use 3 sets of tick marks and 4 sets of tick marks from this particular property, because we don't know if these links match anything else that's going on in the picture. We just know that they are congruent to each other. Okay, now our parallelograms, which is what we've been talking about exclusively so far, may actually be a more specific type of a shape if we can find additional properties to go along with the ones that we've already talked about. So we've already got both sets of opposite sides parallel, both sets of opposite sides congruent, both sets of opposite angles congruent, and our diagonals bisect each other. But let's say also that your parallelogram was equiangular. Okay, now, so we're not just saying that the opposite sets of angles are congruent, but now let's say that all 4 of the angles are congruent. And if that's the case, then you have a new term, rectangle. A rectangle is a parallelogram that is equiangular. Okay, so it's going to take your parallelogram and all of the properties that we've talked about so far, and for lack of a better way of putting it, it's going to make it stand up straight. Okay, our parallelogram was kind of slouching over to one side before. No longer can it do that because of all of the right angles in it. It's equiangular. It's going to cause all of those angles to be right angles. Now, after you decide that your shape is a rectangle and not just a parallelogram, okay, something else also happens. The diagonals that a moment ago were bisecting each other, as it turns out, in a rectangle, your diagonals are going to be completely congruent to each other. So when they bisect each other, now it's not 2 pieces that are one length and 2 pieces that are a different length. Now all 4 pieces of the diagonals are congruent to each other. Obviously, these last 2 diagrams is not something that you can add in to the original diagram of a parallelogram, because we're not talking just parallelogram anymore, we're talking rectangle. So hopefully you've been drawing some new pictures on these last 2. Now, something else could have happened back on your parallelogram. So we're not talking about rectangles anymore. Now we're saying, hey, I've got a parallelogram. And it's not just that the opposite sets of sides are congruent. As it turns out, all four of my sides are congruent. So it's equilateral. So if you decide that your parallelogram is equilateral, then that makes it become a rhombus. Now, hopefully all these names of these shapes, okay, you've heard all these before, so hopefully it's nothing new. We're just refreshing your memory and getting some new properties involved. Okay, so there's a new diagram for you, our parallelogram, but it's all four sides are congruent. It is equilateral. That makes it a rhombus. Now there's another property that goes along with being a rhombus, and just like with the rectangle, it deals with the diagonals. Okay. Now, with a parallelogram, when the diagonals intersect, they bisected each other, but it didn't tell us anything about the measurement of the angle or the angles where the diagonals made contact. And that's fine because we don't really know much about them. But if you have a rhombus, when the diagonals intersect, it's actually going to cause a whole bunch of right angles there at the intersection. So that means our diagonals are perpendicular. So there's a new diagram for us, a new property. And then there's one other type of parallelogram that we have not discussed yet. And this would be the situation where we find properties of a parallelogram, but then also find properties of a rectangle and find properties of a rhombus at the same time. A rectangle does not have properties of a rhombus, and a rhombus does not have properties of a rectangle. But if you find properties of both rhombuses and rectangles at the same time, now you have your good friend, the square. Okay. So square is probably the second shape that you ever learned, back in your days of pre-K. But as it turns out in geometry, it is actually a very complicated shape with a lot of properties. The first shape that you probably learned back in the day was the circle. And as you will see, it is one of the most complicated shapes that we will have in all of geometry. We'll be getting to circles shortly. Okay. But of course, remember there, as it says on the right side, a square is regular. Remember that the term regular is the word that means equilateral and equilateral. I'm sorry, equiangular and equilateral at the same time. Now, parallelograms are not the only type of quadrilaterals that are out there. Okay, so let's look at a couple of other kinds. These won't take nearly as long because they don't have nearly as many properties. Okay, let's say our quadrilateral did not have both sets of opposite sides parallel. Let's say it only had one set of opposite sides parallel. We would not call that a parallelogram. We would call that a trapezoid. Trapezoids have only one set of opposite sides parallel. There are not any properties that we're going to go over about a trapezoid because, quite frankly, they do not have properties like a parallelogram did. Okay, but it's important to know the difference between a parallelogram and a trapezoid because you definitely do not want to apply parallelogram properties to a trapezoid shape. If you do that, you're going to get all kinds of wrong answers. And another main type of quadrilateral that we deal with, and you may not have heard of this one before, it doesn't have anything to do with sides being parallel like the parallelogram did, like the trapezoid did. This one deals with side lengths. Okay, and what this one wants is two sets of consecutive, meaning in a row, congruent, meaning same measurement, sides. Two sets of consecutive congruent sides, and that shape is referred to as a kite. Okay, so if you've ever played with a kite or flown a kite or seen a kite or whatever and wondered where they came up with such a name like that, well, here it is. This is the shape that a kite is. Two sets of consecutive congruent sides. And again, notice the differing styles of tick marks, because we do not have all four sets of sides, or all four sides congruent. If all four sides were congruent, that would be a rhombus, not a kite. Once again, there is another property that goes along with being a kite, and once again, it deals with the diagonals. Okay, if you draw in the diagonals of a kite, a couple of things happen. And the statement that describes it all is that one diagonal is a perpendicular bisector of the other diagonal. Okay, well, we talked about this word perpendicular diagonal, perpendicular bisector earlier in the year when we were talking about triangles. So as you can see in the diagram, one diagonal is cut exactly in half, and the intersection between the two diagonals is a right angle. Sorry, I hope you could hear all that through the announcement that came through on the PA. Okay, and again, differing styles of tick marks on that diagonal that's bisected, because we do not know if these two lengths match any other length that's going on inside of the diagram. So we use a new set or style of tick marks. Okay, now there's a lot of shapes that we've kind of covered here or reviewed here. Okay, so what I'm going to do now is I'm going to look at a tree diagram that kind of ties all of this together. Maybe gives you a visual of how all this stuff is related. So if you're to look at a tree diagram of all these shapes, this is what it's going to look like. And this is definitely something that needs to be in your notes. First off, at the very top of the tree diagram is our term polygon. Remember, a polygon is simply an enclosed figure built entirely out of line segments. That is what much of geometry is based on, is the polygon. Okay. Specifically, today we are looking at the quadrilateral. So quadrilateral is like a subset of polygons. There are polygons that are not quadrilaterals, but all quadrilaterals are polygons. Now, there's three distinct subgroups of quadrilaterals if you can find certain properties that we just discussed. Okay, those different subgroups are the parallelogram, the trapezoid, and the kite. So if you look at your four-sided polygon and you find that you have two sets of opposite sides parallel, then you have a parallelogram. If your four-sided polygon only has one set of opposite sides parallel, then you have a trapezoid. If your four-sided polygon doesn't have any sides parallel, but it has two sets of consecutive congruent sides, then you have a kite. And again, parallelograms, trapezoids, kites, these are all types of quadrilaterals, but not all quadrilaterals will fit into the category of being parallelograms or trapezoids or kites. They've got to have certain properties. Now, trapezoids and kites, that is as far as we can classify anything. However, there's other stuff that can happen with the parallelograms. So you're looking at your parallelogram, and you decide that it has all of its angles are the same, or it's equal angular. That would make it a rectangle. Or you look at it and you decide it's equilateral. That would make it a rhombus. And once again, rectangles and rhombuses are types of parallelograms, but not all parallelograms are going to be rectangles or rhombuses. You have to find the right properties to make the rectangle or the rhombus happen. And if you can find properties of a rectangle and a rhombus at the same time, then that brings you to the square. Okay, so again, squares are rectangles and rhombuses at the same time, but not all rectangles and not all rhombuses are squares. So you can kind of, if you can get the tree diagram kind of memorized, that'll help you see how things are organized and what properties will come along. Okay, so as we've kind of been saying, things at the top may become things in the lower levels if they have the necessary properties to do so. When that happens, they pick up the new properties that go with the new names, but they still retain the old properties. So everything that we talked about, I mean, look at square for an example. It's got its properties, but it also has the properties of a rectangle. It also has all the properties of a rhombus. It also has all the properties of a parallelogram, all the properties of a quadrilateral, all the properties of a polygon. Okay, so the further down the structure, the tree structure it goes, the more properties it's going to pick up. Square is a very complicated shape with a lot of stuff going on. Okay, that is it. I appreciate you finding time to tune in and do your notes. I will see you in class when we meet next.